So in this question, we have to form a 2 by 2 matrix, which is going to be both symmetric and skew-symmetric. So a 2 by 2 matrix will have the elements A11, A12, A21, A22. Now, for this matrix to be symmetric, we should have Aij equals to A of Ji, and if it has to be skew-symmetric or antisymmetric, then it should also follow that A's of Ij must be equals to the negative times of A's of Ji. Now from this we get A's of Ij minus A's of Ji equals to 0, and from the second condition we get A's of Ij plus A's of Ji equals to 0. Now for this we can add them. So when we add together, what we get is 2 of Aij is equals to 0, which implies A's of Ij is equals to 0. Then we substitute the value of A's of Ij in the first one, then that gives us A's of Ji is equals to 0. So that would mean each of the element must be 0, then this will give us a matrix which is going to be both symmetric and skew-symmetric. So it's a 2 by 2 matrix. So a 0 matrix is a matrix which is both symmetric as well as a skew-symmetric matrix. So in this question, we are given a 3 by 3 matrix A. What we have to do is we have to find out the value of x. Now since this is a skew-symmetric matrix, we know that it follows the rule that A's of Ij, the element A of Ij, is B equals to the negative of A of J of I. So if we look at the matrix, so this is our x, so this element is in the third row, first column. So this is equals to x. So since this matrix is a skew-symmetric matrix, for this matrix to be skew-symmetric, we know that this value must be equals to the negative of A, the element in the first row, third column. So x must be equals to negative of, what's the element in the first row, third column? So the number here is negative 2. So we replace A13 by negative 2. So this gives us x is equals to 2. So that is the value of x. So here we're provided with two matrices. One is the transpose of matrix A, so this is a 3 by 2 matrix, and B is another matrix which is a 2 by 3 matrix. So using these two matrices, we have to find out the value of A transpose minus B transpose. We already have the value for A transpose, so let's find out the value of B transpose. So B transpose, what we do, we take the rows and convert it into a column. We just have to flip it. So we take the first row, which has the elements 1, negative 1, 2 and 1. So we turn it into a column matrix. So this will be negative 1, 2, 1. And the second row having the elements 1, 2 and 3 will go into the second column. So now that we have A transpose and B transpose, let's quickly figure out what's the value of A transpose minus B transpose going to be. So we take the matrix A transpose, which is 3, negative 1, 0, 4, 2, 1, and we subtract B transpose, which we just found out. It's negative 2, negative 1, 2, positive 1, 1, 2, and 3. So this should give us 3 minus of 1, so which is 3 plus 1. So this is going to be 3 plus 1. Then we have 4 minus of 1, negative 1, minus of 2. Then we have 2 minus 2. 0 minus the minus of 1 should make it a positive 1. So we have 1 minus 3. So let's solve this. And this should give us 3 plus 1 is 4, 4 minus 1 is 3. Negative 1 and negative 2 gives us a negative 3. 2 minus 2 gives us a 0, 0 plus 1 gives us 1, 1 minus 3 gives us a negative 2. So that is the value of our matrix. So we're given a matrix A, which is a 2 by 2 matrix, and then we have to find out the value of A plus A transpose. So what we do is first we find out the value of A transpose. So what we do, we take the element in the first row of matrix A, which is 1 and 2, and convert it into a column. So this goes into the first column. Then we consider the element in the second row, R2, which is 3 and 4, and then write it in the second column. So 3 and 4. So there we go. We have the value of A transpose. What we do, we're going to add A transpose to A. So that should give us 1, 2, 3, 4. This is added to the matrix A transpose, which is 1, 3, 2, 4. We add the corresponding elements, so that should give us 1 plus 1. Let's write it down. 2 plus 3, 3 plus 2, and 4 plus 4. So if we simplify the values, that should give us 2, 5, 5, 8. And this is a symmetry matrix. So this is the value of A plus A transpose. Then the final question, we have to find out the value of X. So these are equal matrices. What we can do, we can quickly equate the values. Twice X plus Y equals to 6. So this would be the first equation. And the element in the first row, second column, which is twice of Y, this will equate to 0. Then we divide both sides by 3. So we'll get 0 divided by 3, which is always 0. And we plug in the value of Y equals to 0 into our first equation. So that should give us twice X plus 0 equals to 6. So that will mean twice X is equals to 6, dividing both sides by 2. So we should get 6 divided by 2, which is equals to 3. So that's the value of X.